On a cloudy Wednesday night, October 29th, 1969, programming student Charlie Klein was sitting in front of a terminal similar to this one on the campus of UCLA making notes in his work log. At 10:30 p.m., Charlie made history for being the first person to send a message over what we now call the internet. Charlie typed in the words login and waited eagerly as the message was transmitted. Well, as luck would have it, the system crashed after only the first two letters were transmitted. About an hour later, the offending code that caused the crash was fixed and the full login was transmitted. So, the very first messages sent over the internet will always remain low. Speaking of internet, we're going to talk about the different ways we can provide internet access to our VPCs. We're going to talk about internet gateway, egress-only internet gateway, and the NAT options that we have. Now, Internet Gateway is a horizontally scaled, redundant, and it's highly available, and it allows your VPC to communicate with the internet. Now, there are no availability risks because it's redundant, and there's no bandwidth constraints. And if your subnet is associated with a route to the internet, then it's a public subnet. And Internet Gateway supports both IPv4 and IPv6. Now, it fulfills two purposes. The first is it provides a route table target for internet-bound traffic. And purpose number two is it performs NAT for instances with public IP addresses. Now, for purpose number two, there's an important distinction here. Inside your VPC, all instances are known to each other by their private IP address. Their public IP address, if assigned, comes in only when they're trying to access the internet or being accessed from the internet. An instance that only has a private IP assigned, regardless of whether it has a route to the internet gateway, cannot get access to the internet. So the takeaway here is the internet gateway does not perform NAT for instances with private IPs only. So egress-only internet gateway exists only for one reason, for IPv6, because on AWS, IPv6 addresses are globally unique, and therefore they're public by default. In comparison, IPv4 addresses have a private range assigned by RFC 1918, and as such, they can't be accessed from the public internet. For IPv6, though, you don't need to use a NAT instance for private or public conversations, but you do need an internet gateway or an egress-only gateway to the internet. Now, the difference between an internet gateway and an egress-only gateway is that the egress-only gateway is only outbound. It prevents inbound access to those IPv6 instances. It is stateful, meaning that it keeps up with the connections and it forwards traffic from the instance to the internet and then back. Just like a normal internet gateway, you're going to have to create a custom route to route the egress-only traffic to that egress-only gateway. And this is what you'd use for IPv6 instead of a NAT instance, like you would for IPv4. Then we have the NAT instance. Now, the NAT instance is just an EC2 instance that's running a special version of a Amazon Linux AMI. And its only purpose in life is to translate traffic from many private IP instances into a single public IP instance and back. And it doesn't allow any public internet-initiated connections into those private instances. Now, it doesn't support IPv6, that's where egress-only gateway comes in. And the NAT instance must live on a public subnet, and it has to have a route to the internet itself. To make use of that NAT instance, you're going to have to create a default route in your private subnet to provide a path for your private instances to get to it. We also have the NAT gateway. Now, this is a fully managed NAT service, and it really replaces the need for a NAT instance on EC2. And it must be created in a public subnet, and it uses Elastic IP for its public IP address. And just like a NAT instance, you have to set up a default route to that NAT gateway. It's created in a specific AZ and it has redundancy within that zone. Now, if you want multi-AZ redundancy, you can create NAT gateways in each AZ and create localized routes for the private subnets in those respective AZs to go to their own AZ version. There is a limitation on bandwidth here. AWS guarantees 5 gigabits of bandwidth, but you can scale up to 45 gigabits. Now, you can't use the NAT gateway to access VPC peering, VPN connections, or direct connect connections. So you're going to have to be sure to include specific routes to those networks in your route table. And remember, the most specific route in your route table is the one that gets selected first. Let's take a look at the comparison between a NAT instance and a NAT gateway. And this is relevant for the exam because you'll probably get a few questions on this. So as far as availability, the NAT gateway is naturally the better option for availability. For a NAT instance, you're going to have to architect your own high availability solution. For bandwidth, the NAT gateway can support up to 45 gigabits. The NAT instance is really dependent on what sort of instance you provision it. For maintenance, the NAT gateway is managed by AWS, and for the NAT instance, you're on your own again. So as far as performance, the NAT gateway is really optimized for network address translation. The NAT instance really is just a conscripted Amazon Linux AMI that's configured to perform NAT. Now, the NAT gateway's public IP is an elastic IP that cannot be detached once you create that gateway. Now, with an instance, you have flexibility where you can detach and attach other elastic IPs. You can't associate a security group with a NAT gateway, but you can with a NAT instance. And you can also use a NAT instance as a bastion server if you'd like, because it really is just a little Linux system. Overall, AWS recommends using a NAT gateway over a NAT instance because it's scalable, it's highly available, and it's fully managed.